Okay, my first recommendation in this problem is to try to rewrite that summation in summation form. And looking at it, I'm looking at this thing and I'm seeing things that do change in the sum. So I'm seeing 1, I'm seeing 2, I'm seeing 3, and it goes up to n. So I'm gonna write that down now as the sum. I'm gonna start the counter at 1. So I equals 1. And let's write this down. So I'm seeing 1 over n, and then I'm seeing an n here. Every single time I'm seeing that. And then I'm going to put the I here, and then I'm going to square it. And it's going to give me what's up there, which is good news. Now, where's this going? From I equals 1 to n, but I'm definitely taking a limit of that. And that n goes to infinity. All right? Now, certainly they want me to write the integration down. And writing the integration down, my emphasis on writing integration down is it can be incredibly difficult, but they're kind of setting it up so it doesn't look that bad. So I'm going to say it looks like something to do with a square problem. So what I would do is, say maybe start at 0, and I'm starting to see the length of the integral is 1. Now, someone's going to say, I want to start at a different number. You can, but I'm thinking 0 to 1 is the length of 1. Starting at 0 looks like an easy place to start counting from. And it looks like maybe it's a parabola. And you realize I'm doing a Riemann sum over here. And so I'm going to divide the interval into n equal pieces. So that would be 1 over n. And what do? You kind of put little rectangles in. What's the first one going to be? Well, it's going to be 1 over n squared. And the function over here, f of x, is x squared. What's the next guy going to be? Well, it's this guy over here. This is a right endpoint, by the way, plus 1 over n. Oh, that's 2 then, 2 over n. And this looks like the ticket. So I'll write this over here for you. This would be an integral from 0 to 1, x squared dx, which is relatively simple to evaluate. It's going to be x cubed over 3, 0 to 1, and that would be 1/3. All right? So, I'm saying that's what they asked you to do. I did it. And I want to emphasize that this is really what they wanted me to do. Get this over here. And I got that. I have the value. They didn't ask for it. So what I want to do is I want to talk about how to evaluate this. Give me 1 second. Sorry, I lost something there. I don't know what happened. I want to evaluate this thing over here. All right? Let me write that down for you. So the sum, we'll do the limit later, by the way. I equals 1 to n, 1 over n, I squared over n squared. All right, I'm going to keep writing this over here. This is 1 over n cubed. I'll do limit later. The sum, I equals 1 to n I squared. Well, these are formulas that we've described to you in classroom, and it goes back to really your pre-calculus days where you did sums of the integers squared from 1 to n. So let's write this over here, 1 over n cubed, and that sum is going to be n plus 1, I'm doing this over here now, 2n plus 1 over 6, all right? Now, what do I got to do now is I got to do the limit part. So I want to point out what I just did. I did this part. That's all I did. Now you put the limit in. Limit, n goes to infinity. Whoops, get my eraser out. Equals limit, n goes to infinity. Well, I'm going to do that. Limit, I hope I get 1/3 too, right? 6. I'm going to take this n cubed, divide it into 3 parts, n, and n. N into n goes 1 time. Into the next guy is going to be 1 plus 1 over n. The next guy, dividing by n, you get 2 plus 1 over n. What does that give you in the limit? Well, it gives you 1 times 2 on top, 6 on bottom, 1/3. We get the same answer. Thank you.